I'm Parkavi, pursuing my final year ME Computer Science and Engineering at KSI Institute for Engineering and Technology. My project is abstraction-based K-tier partitioning scheme for parallel job scheduling in multiple cloud centers. Here I am going to partition the data centers at multiple countries where the resources are pooled in a n number of data centers. So the resources are scheduled and rendered to the users in a specific manner uh, to make effective in a resource scheduling and to do not make a server to under resource utilization. I take this project in my project. The underutilization of resources and improper scheduling will be tackled by abstraction refinement. In abstraction refinement, the abstract representation of data centers and its resources availability are detailedly shown, and which is more helpful for the scheduler to schedule the resources to the users in an effective and most cost effective way. Now I am going to start my implementation of my project. First, I use here NetBeans and CloudSim for my project. I already incorporate CloudSim package to this NetBeans, so I just simply open the recent project, which is named as Phase 2. Now the project is built. Here Phase 2 is the project. Here source packages. In the source packages, in the example folder, my codings are put inbuiltly embedded. Here pjs.java. This is the start file of my project. Here in the package org.cloudbus.cloudsim.examples, I have embedded this my project in a Java platform, which is more flexible for running the projects in a simulation environment. I here set up the cloud in a simulation environment by using NetBeans and Cloud Simulator. Now I am going to run this running files. Now the output will be displayed in a specified window. Abstraction based K-tier partitioning scheme for parallel job scheduling in multiple cloud centers. This is my title. And first going to job list. Here I have created 45 users with the coordinates, process name, bandwidth, record time and record insertion. Here the process denotes the user's needed process. For example, user ID 1 needs a process Google Nexus 7 tablet, and the bandwidth of the process is 454, record time is 438, record insertion is 454. Likewise, I have created 45 users with the required process they needs. Next, parallel workload generation. Now the user will select the process and render for getting those process from the cloud. Once it is selected, it is given to the cloud data center, and scheduling operation is performed. After the scheduling operation, the resources will be allocated to the user based on their needs. First, for example, user 1 needs a job 1. Here the user ID, process ID, coordinates, bandwidth, require time all displayed. For example, user 2 may also need a same process which is needed by the user 1. Similarly, user 3 will need another process which is named process ID 2. Similarly, the fourth process, same process ID may also be needed. For example, process user ID 4 needs second process which is already needed by third process. Similarly, fifth user may need a job which is already needed by first user. Similarly, sixth process fifth user may need some other process. that is second process. And fifth user sometimes may need another process also. So sixth user also need fourth process. This is the request job list generation. Now based on the user needs of the process needs, scheduling is performed and it is allocated to the user. The processes are allocated to the user based on the scheduling. The existing scheduling algorithm is gang scheduling algorithm. In gang scheduling algorithm, the process, a single user may need one or more process. So group of resources are rendered to a user for a particular time interval. For example, the sixth user may need fourth process and second process. So for some particular interval, fourth process is allocated to 6, and next particular interval, second process is allocated to sixth user. But the execution will be available for a particular time slot only. So there may be delay of execution, and also underutilization of resources may cause in gang scheduling. So for this, we are going to consolidate those workloads. So workload consolidation. In workload consolidation, we first gather what are the user need the same particular process. For example, user first, second and fifth one need the same process first. User 3, 4 and 6 need the same process too. By consolidating this workload, it will be more effective for scheduling those resources. Next one, conservative migration. This is another scheduling algorithm which is CMCBF, conservative migration and consolidation supported backfilling. Here the VMs are directly allocated to those users. Here for example, VM1, for VM1 process ID 1 is allocated, which is needed by the user 1, 2 and 5. Similarly, VM4 is allocated to process ID 4, which is needed by user 6th one. Here the VMs are allocated based on their threshold value. That is, for VM1, the value for VM, for example, wait, I will show the values allocated for event. For VM1, bandwidth is 300 to 500 and the maximum is 500. For VM2, the bandwidth allocated is 200 to 300 and maximum is 225. Similarly, for VM3, the bandwidth allocated is 0 to 200 and the maximum bandwidth is 150. Similarly, for VM4, bandwidth allocated is between 500 to 999 and the maximum is 975. By using this list, the VMs are allocated. Similarly, process ID 454 is allocated into VM1 since VM1's maximum bandwidth allocation is 500. So the process ID 1 is allocated to VM1. Next, background and foreground. This is the same to CMCBF, in which here foreground and background jobs are allocated. In foreground, high priority CPU jobs are allocated. In background, low priority CPU jobs are allocated. Since here the process 1, which has 454 bandwidth, is allocated to VM1 of foreground, and process ID of bandwidth 395 is allocated to background of VM1. Likewise, here the virtual machines are run parallelly at both the foreground and background to make use of node utilization. In gang scheduling, there will be no node utilization, but in CMCBF, the node utilization is effective by partitioning the VMs into two tiers, namely foreground high priority and background low priority. And next one is abstraction scheduler. This is our proposed method where abstract representation of the data center resources are defined, and based on this the users requests are satisfied by allocating particular data center resources to the users which is available. And the main thing about the abstract refinement is The availability of the data center resources are checked dynamically, and once if the resource is available, it is allocated to the user who needs. There will be no waiting time in abstraction scheduler, which is overcome of the existing systems. Here, VM4, that is virtual machine 4, have the resources 4 that is Toshiba Canvas Basic 3.0 plus 1 terabyte. This is available in virtual machine 4. And also similarly, VM1, that is virtual machine 1, have the resource process 1 and process 2, that is Google Nexus 7 tablet and SanDisk Browser Blade. These two processes are available in virtual machine 1. Now these processes are needed by 6, and the process 1 and process 2 are needed by the users 1, 2, 5, 3, 4 and 6, which are available in the virtual machine 1. So there will be scheduling only in this virtual machine resources, not in the base, not in the existing overall virtual machines, since the virtual machines are partitioned based on their resource availability, so the time consumption will get reduced. Now data center and data center abstraction. Here data centers are partitioned based on the coordinates. For example, there are north, south, east and west coordinates. So based on the location, the data centers are partitioned. For example, partition ID1, that is data center 1 will be at the north to east region, and it is located at Berlin, which the resources process 1 is located at virtual machine 1 of Berlin, and it is needed by user ID 1, 2 and 5. It is allocated to 1, 2 and 5. Similarly, New York, Jersey and New Jersey are the data centers which is partitioned as partition ID 2. Here the process ID 4 is located in the virtual machine 4, and which is needed by the 6th user, and it is satisfied to the 6th user. Similarly, data center partition 3 is at locations largest city Lagos and San Francisco, in which virtual machine 1 resources are incorporated in process 2. The process 2 is SanDisk Browser, which is located at BM1 of San Francisco City Lagos Lajas, which is needed by user 346. Hence here, by partitioning the data center based on the location and also with the resources in the virtual machines, there will be easy scheduling of resources to the users in a parallel execution manner, and also at the same time the time consumption also get reduced, and network traffic will be reduced, since if virtual machine 1 did not have those resources, if it is overloaded, means the virtual machine 1 will move those resources to the another virtual machine which is closer to that region. By using this coordinate access, it is so helpful to find which virtual machine is near to particular virtual machine. This is my project. Thank you.